Deep learning, deep learning, deep learning. So the most popular topic nowadays we are hearing is deep learning. So in this, we are going to see what is the introduction, aim and objectives, review of deep learning concept, review of related works and specific application areas. What are the practical application of deep learning, problem scenario trends and research issues, conclusion references, etc. So, deep learning is nothing but a transitive subset of artificial intelligence via machine learning. So here we can see a artificial intelligence and afterwards machine learning, and after all these we have deep learning. So deep learning is nothing but a subset of machine learning, and machine learning here we can see it is a subset of AI. So deep learning is related with the neural networks, decision making, etc. So what is artificial intelligence? The theory and development of computer systems that are able to perform tasks normally requiring human intelligence, such as visual perception, speech recognition, decision making, and translation between languages. So artificial intelligence includes following areas of specialization, such as game playing, robotics, natural language processing, expert system, neural networks. Here we can see some applications of artificial intelligence are chess playing game, number plate recognition, Siri, that is Google automated. So AI technology's timeline, coming to the artificial intelligence, from which year we have got this technology? From 1950s we have artificial intelligence, engineering of making intelligent machines and programs. Machine learning, something around 1980s. It is the ability to learn without being explicitly programmed. And 2000s, deep learning, learning based on deep neural network. So what is machine learning? Machine learning is a type of artificial intelligence that provide computers with the ability to learn without being explicitly programmed. So here we can see the process that involved in machine learning. New input will be given to a machine. Here this is going to learn from the data set. The data set is going to help the machine to recognize the images, flowers, etc. So what are the limitations or drawbacks of machine learning? One of the big challenges with traditional machine learning models is a process called feature extraction. For complex problems such as object recognition of handwriting recognition, this is a huge challenge. Deep learning to the rescue. Deep learning modes are capable of focus on the right features by themselves, requiring little guidance from the programmer. These models can also partially solve the dimensionality problem. The idea behind deep learning is to build learning algorithms that mimic the brain. Here we can see the different drawbacks of machine learning. So, what is the main aim of this seminar presentation is to review the concept, architecture, algorithms, trends, and research issues in deep learning. So here our main objective is to discuss the concept of deep learning by way of definition, architecture, and basic algorithms. To review related works and highlight specific application areas, to bring to the fore the various research issues and trend in deep learning. So what is deep learning? A class of machine learning techniques that exploit many layers of nonlinear information processing for supervised or unsupervised feature extraction and transformation, and for pattern analysis and classification, according to 2014. So it typically uses deep artificial neural networks. What is deep learning actually? A subfield of machine learning that is based on learning several levels of representations corresponding to a hierarchy of features or factors or concepts, where higher level concepts are defined from lower level ones, and the same lower level concepts can help to define many higher level concepts. So here we can represent deep learning as a combination of machine learning plus representation learning. Representation learning is a set of methods that allows a machine to be fed with raw data and to automatically discover the representations needed for detection and classification. Why is deep learning happening now? Actually, it is not. First papers published in 1970s itself. Third, resurgence of neural networks, research breakthroughs. So, what is the vanishing gradient problem? Sigmoid type activation functions easily saturate. Gradients are small. In deeper layers, updates become almost zero. What is the solution for this? Earlier, layer by layer pre-training, recently non-saturating activation functions. What is gradient descent function? So what is the problem with this gradient descent? First order methods, example SGD, are easily stuck. Second order methods are feasible on larger data. Adaptive training, AdaGrad, ADAM, ADA Delta, RMS prop, Nestrov momentum. Next, what is regularization? So the problem is networks easily overfit even with 12 regularization. The solution is dropout. So it increase in computational power, GPUs. How deep learning works? Let's understand the work of deep learning. Deep learning is implemented through neural networks. Motivation behind neural networks is the biological neural. We all are having the neurons, how they are going to work internally. That is the main motivation for neural networks. So in our brain, so in our body, the biological neuron, it is composed of dendrite, cell body and axon. Dendrite is, it receives signals from other neurons. Cell body sums all the inputs. Axon, it is used to transmit signals to the other cells. So what is the schematic for a neuron in a neural network? Here, if you see the schematic for a neuron in a neural network, it is represented as inputs x1, x2, x3, so on up to xn, with the weights associated with x1, w1, x2 is w2, x3, w3 and so on, xn, wn. The transfer function sigma is used. Here the activation function is used and the output is represented as y. This is the schematic for a neuron in a neural network. What are the unique characteristics of deep learning? Automatic feature extraction, we can automatically extract the features. Makes use of high dimensional data for training. Because of the use of that high dimensional data, accurate results may get. Defines higher level features from lower level features obtained from the previous layer. It is going to define the higher level features from the lower level features which are obtained from the previous layer. It is a representation learning method. It can solve real world or unconstrained problems such as natural language processing, image recognition, etc. What are the software that are associated with deep learning? You can see the following are the list of some deep learning softwares, but they are not limited to TensorFlow, Theano, Torch, Keras, Blocks, CAF, CAF2, MXNet, MAT, ConvNet, Microsoft Cognitive Toolkit, Deep Learning 4J, DLib, but not limited to this. Categories of deep architecture with algorithms: supervised or discriminative deep learning, unsupervised or generative deep learning, hybrid deep architecture. Coming to the supervised or discriminative deep learning, what actually it is? Convolutional neural networks, simply represented as CNNs, they are a subtype of the discriminative architecture, is the CNN. The convolutional neural networks is one of the most notable deep learning approaches where multiple layers are trained in a robust manner. Example, listen, Boto, Bengio and Hafner 98. We have gathered the information. So here pipeline of the general CNN architecture is represented in the as follows. A image is being given as a convolution. Okay, here the convolution layers plus pooling layers, max pooling, they are going to connect to the fully connected layers. And here whatever the images that we are going to give as an input will be identified. For example, whether it is a dog, person, cat, bird, fish, fox, etc. So CNN in action, facial recognition is one of the most popular application that is used in the CNN. Okay, so here in the figure, this learned hierarchical features from a deep learning algorithm. So when you give a different images representing the faces of different persons, this will be converted into this data set will be taken as the input, and it is going to perform the exact accurate results. What is unsupervised or generative deep learning? This is restricted Boltzmann machines, RBM. Here we can see schematic structure, visual variables. Here we are having V2, V1, V2, V3 and H1, H2, H3, H4. So what are the variants of restricted Boltzmann machines? Here we can see A, the DBN and DEM. Here we are going to have the three layers, DBN, DBM and DEM. In the first one we can see how these are having different layers starting from 1, 2, 3 and 4. So the variants, these are nothing but the variants of restricted Boltzmann machines. Autoencoder. What is the autoencoder going to do? The pipeline of an autoencoder is clearly represented here. First we take the input, we give the input to the encoder and it will code and it will send it to decoder, and after that it will reconstruct. The reconstruction is there. If there is any error at the output, then this will be propagated back. Okay. Next, the theoretical literature review. If you see how this learning algorithms, how the representation learning, how the overfitting techniques, how the optimization methods and deep learning variants will help in the literature review. So learning algorithms, coming to this table represents or describes a categorization of the basic deep neural network learning algorithms and related approaches. We can see the comparison or the brief categorization. CNN, convolution neural networks, RBM, autoencoder and sparse coding. So here in the CNN AlexNet, approximately 2012. RBM, deep belief net. Autoencoder, sparse autoencoder. Sparse coding, sparse coding. In CNN again, clarify. RBM, deep Boltzmann machine. Autoencoder, denoising autoencoder. Sparse coding, Laplacian sparse coding. And CNN, SPP, RBM, deep energy models. Autoencoder, contractive autoencoder. Sparse coding, local coordinate coding. And coming to CNN again, VGG. In sparse coding, super vector coding. In CNN, Google Net. What is representation learning? Here we need to discover a fast and more efficient way of initializing weights for effective learning of low dimensional codes from high dimensional data in multi-layer neural networks. What is the contribution here? We are implementing a novel learning algorithm for initializing weights that allow deep AE networks and deep Boltzmann machines to learn useful higher representations. And what is the second research focus is to explore the possibility of allowing hashing function learning. That is the learning of efficient binary codes that preserve neighborhood structure in the original data space, and feature learning occurs simultaneously. Contribution is introduction of a state-of-the-art deep hashing, supervised deep hashing and semantic hashing methods for large-scale visual search, image retrieval and text mining. And third one, the main research focus on third one is to bridge the gap between the success of CNNs for supervised learning and supervised learning. Contribution, introduction of CNN called deep convolution. Here we will introduce new deep convolution, new adversarial network for unsupervised learning. So overfitting techniques. Here, what is the main research focus? To mitigate the problem of overfitting in large neural networks with sparse datasets. Contribution, implementation of several regularization techniques such as dropout, stochastic pooling, weight decay, flipped image augmentation amongst others for ensuring stability in DNA. And what is the second research focus? To investigate how to automatically rank source CNNs for transfer learning and use transfer learning to improve a sum product network for probabilistic inference when using sparse datasets. Contribution, design of a reliable theoretical framework that performs zero-shot ranking of CNNs for transfer learning for a given target task in sum product networks. What are the optimization methods? The main research focus is to develop a computationally efficient algorithm for gradient-based optimization in deep neural networks. The contribution here, we are going to introduce several first order and second order stochastic gradient-based optimization methods for minimizing large objective functions in deep networks such as complementary pairs, ADAM, ADAGRAD, RMS prop, momentum, LBFGS, and Kalman-based SGD. The second one is to develop an accelerator that can deliver state-of-the-art accuracy with minimum energy consumption when using large CNNs. And the contribution is implementation of an energy-efficient reconfigurable accelerator for deep CNN using efficient data flow to minimize energy through zeros skipping gating. Deep learning variants. So the main research focus is to demonstrate the advantage of combining deep neural networks with support vector machines, SVMs. The contribution here, introduction of a novel classifier architecture that combines two heterogeneous supervised classification techniques, CNN and SVM, for feature extraction and for classification. The research focus number 2 is to exploit the power of deep neural networks in optimizing the performance of nearest neighbor classifiers in KNN classification tasks. The contribution, they presented a framework for learning convolutional nonlinear features for K nearest neighbor classification. Application, literature review, methodology, application of deep learning, domain, application of deep learning has been applied in so many ways to solve real life problems. What is the methodology application of DL? To improve the performance of sentimental analysis, enhancing deep learning sentiment analysis with ensemble techniques in social applications. And deep learning methods on recommender system, a survey of state of the art. A deep learning approach for credit scoring using credit default swaps, deep learning for plant identification using Wien morphological patterns, predicting process behavior using deep learning, a deep learning based emergency alert system. Here, what are the domain applications of deep learning? The domain is first one, recommender system. Deep learning is applied to perform sentiment analysis, opinion mining, and social applications. Here we go with sentiment analysis, opinion mining, facial recognition. Next, medicine, medical diagnosis, finance, credit scoring, stock market prediction. And transportation, deep learning is applied to perform traffic flow prediction. And business, if you come to the business application, deep learning is applied to perform process prediction. Coming to emergency alerts will be there. Agriculture, plant identification. Applications of deep learning. Some amazing and recent applications of deep learning are automatic machine translation, object classification in photographs, character text generation, colorization of black and white images, automatic gameplay. Applications of deep learning. Google Lens is a set of vision-based computing capabilities that allows your smartphone to understand what's going on in a photo, video, or a live feed. For instance, point your phone at a flower and Google Lens will tell you on the screen which type of flower it is. You can aim the camera at a restaurant sign to see reviews and other information. See how the Google Lens is one of the beautiful application of deep learning. And translation. This is a situation where you are given words in some language and you have to translate the words to desired language, say English. This kind of translation is a classical example of image recognition. See here, we are having some cookies which have in different languages. That milk chocolate. That milk is nothing but dark chocolate. After translation, we got the meaning dark chocolate. Instant visual translation. So, if you want to get instant, fastest visual translation, this deep learning is very helpful. Self-driving cars. Nowadays, the self-driving cars are very most prominent applications. Self-driving cars. That means without the person, we are able to have that, adopt the technology. Automatic machine translation. Cooking teacher, for example, we need to translate from Mexican to English or English to Mexican. We have this automatic machine translation. Next, what are the trends in deep learning research? Design of more powerful deep models to learn from fewer training data. Use of better optimization algorithms to adjust network parameters, that is regularization techniques. Implementation of deep learning algorithms on mobile devices. Stability analysis of deep neural network. Combining probabilistic autoencoder and manifold learning models. Applications of deep neural networks in nonlinear networked control systems. Applications of unsupervised, semi-supervised and reinforcement learning approaches to DNNs for complex systems. Learning deep networks for other machine learning techniques. Example, deep KNN, deep SVM. What are the research issues or challenges in deep learning? High computational cost, burden in training phase, overfitting problem when the data set is small, optimization issues due to local minima or use of first order methods, little or no clear understanding of the underlying theoretical foundation of which deep learning architecture should perform well or outperform other approaches, time complexity. Deep learning use case. Let's look at a use case where we can use the deep learning for image recognition. Practical application of deep learning in facial recognition. Here the problem scenario is, suppose we want to create a system that can recognize faces of different people in an image. How do we solve this as a typical machine learning problem or using a deep learning approach? Classical machine learning approach, we will define facial features such as eyes, nose, ears, etc. And then the system will identify which features are more important for which person on its own or by itself. Deep learning approach. Now, deep learning takes this one step ahead. Deep learning automatically finds out the features which are important for classification because of deep neural networks, whereas in case of machine learning, we had to manually define these features. Practical applications of deep learning, facial recognition. Here we can see the different images of persons have been given as input. The input layer will take all this data set, the patterns of local contrast we can see, and that will be given to hidden layer 1. This hidden layer 1 is recognizing the face features, and from then to hidden layer 2 where actually the face will be coming, and finally the output layer. So the face recognition using deep networks is very beautiful application. Deep face recognition. Face recognition applications have two parts or phases, namely phase 1, enrollment phase. That is, model or system is trained using millions of prototype face images and a trained model is generated. Generated face features are stored in database. And in the second phase, recognition phase, that is, query face image is given as input to the model generated in phase 1 to recognize it correctly. Here prototype faces will be given, face detection will be done, feature extraction, prototype feature database, retrieve the stored features from feature database, nearest feature classifier. Here you can see query face, face detection, pre-processing, feature extraction, nearest feature classifier. Deep face recognition. Steps within enrollment. The phase includes face detection, feature extraction, store model and extracted feature in database. What are the steps within recognition phase or query phase includes? Face detection, pre-processing, feature extraction, recognition. So here, what is the step 1? The face detection enrollment phase. Multiple faces will be detected. Face needs to be located and a region of interest is computed. Histogram of oriented gradients is a faster and easier algorithm for face recognition. Detected faces are given to next step of feature extraction. And the second step, that is feature extraction. What is the best feature measure that represents human face in a best way? Deep learning can determine which parts of a face are important to measure. Deep convolution neural network can be trained to learn important features. Step 3. Store DCNN model and feature in database. Enrollment phase. And the step 1, in the recognition phase, we need to detect face detection, that is recognition phase. Face needs to be located and region of interest is computed. Here the step 2 is pre-processing, that is recognition phase. Pre-process to overcome issues like noise, illumination using any suitable filters. Pose, rotation can be accounted by using 3D transformation or affine transformation or face landmark estimation. Determine 68 landmark points on every face. The top of the chin, the outside edge of each eye, the inner edge of each eyebrow, etc. Feature extraction. In this third step of deep face recognition, we have to use trained DCNN model which was generated during feature extraction step of enrollment phase. A query image is given as input. The DCNN generates 128 feature values. This feature vector is then compared with feature vector stored in database. Step 4. Recognition phase. This can be done by using any basic machine learning classification algorithm. SVM classifier, Bayesian classifier, Euclidean distance classifier for matching database feature vector with query feature vector. Gives idea of best matching face image from database as a recognition. Conclusion. Deep learning is a representation learning method and the new state-of-the-art technique for performing automatic feature extraction in large unlabeled data. Various categories of deep learning architectures and basic algorithms together with their related approaches have been discussed. Several theoretical concepts and practical application areas have been presented. It is a promising research area for tackling feature extraction for complex real-world problems without having to undergo the process of manual feature engineering. With the rapid development of hardware resources and computation technologies, it is certain that deep neural networks will receive wider attention and find broader applications in the future. Thank you for listening.